Once again, welcome to Home Learning Grade 7 Science Lesson. My name is Fikile Dube. We are just going to look at matter. We are just going to discuss a little bit deep about matter. What is matter? What is matter made out of? The types or the states of matter, the changes of matter from state to state, and the types of the changes of matter from state to state. We are just going to start by defining what is matter. Matter is anything or is any substance that takes up space and has a mass. That is matter. Matter, it is anything that takes up space and has mass. We are going to discuss more about this mass later on. But matter is just anything, any substance, anything that takes up space and has mass. For an example, this pen here, this is matter. Why do we say it is matter? We say it is matter because it takes up what? Space. And it has what? Mass. What do we mean when we say it has mass? We mean that we can weigh it. That is matter. So everything around us is what is matter. Now, matter is divided into three, or there are only three states of matter. These states of matter are solid, liquid, and gas. These are the only three states of matter. What does this mean? It means that we can only find matter in these three states or forms, which are solid, liquid, and gas. Let us just give examples of each state. Let's start with the examples of solid. Let's list all the things that are solids. I will list some, and you at home, you are just going to list more than what I have listed. Solids are any substances that have a definite shape. For an example, this pen in front of me, it is a solid. It is in a solid state. So we have a pen, we have stone, we have Bible, we have a book, and many more other substances that are solid in a solid state. Now let us give examples of the substances that are in a liquid state. They are all what? Matter. Under the liquid state, there are so many substances, but I'm just going to name a few, and we are just going to name as much as you can. Now, liquid, we have water, the obvious one. We have juice. We have tea. We have starch. All those substances that are in a liquid state, they are also what? Matter. Now let's list examples of the substances or the matter that is in a gas form. There are so many substances that are in a gas form. We have an example of water vapor. Water vapor. Water vapor is in a gas form. And we have all the gases. When I talk of the gases, I mean oxygen, nitrogen, oxygen, nitrogen, all the gases are in a gas form or in a gas state. But they are all what? Matter. Why do we say they are matter? They are matter because they take up what? Space and has what? A mass. Now, these states here, which is solid, liquid, and gas, they keep on changing from one state to another. Now, let us look at how do these states of matter changes from one state to another. Now, if I can have something like a table, we have a solid here. We want to change the solid here. We have a liquid here. We have a liquid and we have a gas. Remember, these are the three states of matter: the solid, the liquid, and the gas. But these states here, they keep on changing. They change from state to state. Now let us look at how do they change from state to state. The solid state. We can change the solid state into liquid. How can we change a solid state into a liquid state? We can heat it. For an example, let's make an example of some ice cubes. Ice cubes. Ice cubes are in a solid state. Ice cubes. How can we change ice cubes to a liquid state? We can heat them. And then what are they going to do, these ice cubes? These ice cubes here are going to melt. They are going to melt. And here we have melting. So now we have changed the ice cubes into a liquid state by heating them. What do? When we heat them, they melt. When they are in a liquid state now, we can also change them into the other gas, into the other state, which is the gas. How can we change the liquid state into a gas state? We can also heat it. We have given an example here of the ice cubes. The ice cubes here have melted into a liquid. And now we want to change the liquid into a gas. How can we change the liquid into a gas? We can continue to heat the liquid. What then is the liquid going to do? The liquid, when we heat it, it is just going to evaporate. It is just going to evaporate. Now, when the liquid evaporates into a gas, now it is changing into from a liquid state to a gas state. So we have changed these states. But we can even change the gas state back to the liquid state. Remember, we are using an example of some ice cubes. Let's say maybe in a liquid state, the liquid has evaporated. There is nothing maybe on the pot or on that vacuum, whatever, but you can still change the gas back into the liquid. How can we then change the gas state into a liquid state? This time, we are not going to heat it, but what can we do? We have to change the gas state back to the liquid state. We can cool it. We can cool it. We can cool the vapor. Remember earlier on, we have mentioned water vapor as the gas state. So we can cool the gas. What then is the gas doing while it is cooling? It is condensing. So here we can write condensation. Condensation. That is where in the topic of the water cycle, clouds are formed. Clouds are formed when condensation takes place. It is when the hot air meet the what? The cold air in the atmosphere, and then clouds are formed. So now, we have changed the gas state into a liquid state now by cooling the vapor. And when the vapor is cooling, it is doing what? It is condensing. So we can write condensation here. We can also change the liquid state back into the solid state again. How can we do that? We can again cool the liquid state. We can also cool it. Sorry, because we have to write this clearly. We can also cool the liquid so that it goes back, or it becomes the first state, which is the solid. What then is the liquid doing when you are cooling? What is the liquid going to do when you are busy cooling it? The liquid is going to freeze. It is when then here we are just going to write freezing. Freezing. So now, this diagram here shows us that really matter can changes from one state to another, from one state to another, and back to the first state, just like the ice cube we've changed here. So we can change the gas state back into a liquid by cooling it, which we call it condensation. And we can also change the liquid state back into the solid state by freezing it, which is we still cool it. Now, that is how matter changes from one state to another. Now let us look at the particles of each state. Remember, we have only 3 states of matter, which is solid, liquid, and gas. We are just going to start with the particles of solid. Now, what makes up matter? Remember earlier on, I said this pen is in a solid state, and it is called what? Matter. Matter is made out of atoms and molecules, of course. Now, let us take a look of each particles of the states. Now, let's look at the particles of solid. We're just going to take a look at the particles. How do the particles of solid, a solid substance or a solid object looks like? If I can have a drawing here, where it is a square, the particles of solid are closely pegged together. There is just no space between it. They give no space. They are pegged together. That is the particles of solid. Now, that is why then we say that solid matter in a solid state, the particles of solid are in a definite shape. They give a definite shape. What does this mean? The word definite is just the same as fixed. Fixed shape. They just do not change easily. So these particles here shows us that the particles of solid, they have a definite shape and a definite volume. And a definite volume. Definite volume. They have the definite shape and the definite volume. This state here is called particles that are closely pegged together, which makes it very difficult to break it. So they have the definite shape and the definite volume. So this gives us the picture of the particles of solid. Let us look at the particles then of liquid, because we say there are 3 states of matter, which is solid, liquid, and gas. Now let us look at the particles of solid. You can simply define them as they are closely packed together. Maybe you can write that. Closely packed. They are packed together. They are closely packed together. That is why they give a definite shape and a definite what? Volume. Now let us look at the particles of liquid. The particles of liquid. They are not the same. We can also represent them by a small square. The particles of liquid, they are not as closely packed together as of those of solid, but they are just close together. They have some, say, they give a space in between. Okay? So this is how we can show the particles of liquid. How then can we define the particles of liquid? We can define them as they are not closely packed together. They are not closely packed together. These particles here, they are just free to move, but not that much free. Do they have a definite volume or a definite shape? They do not have a definite shape. They do not have a definite shape. Why then do we say they do not have a definite shape? It means that liquid changes it changes its shape from container to container. Remember, liquid, you can easily pour a liquid. So it changes from shape to shape. If you pour a liquid in a round, a bottle, it takes the shape of the container. We can also write that. Liquid, what does it do? Takes the shape of the container. Liquid takes the shape of the container. Liquid takes the shape of the container. You can put it in a square container. You can pour the same water in a round container. You can pour the same water on the square container. So that is why we say liquid matter or matter that is in a liquid state do not have a definite shape. So it changes from shape to shape. It's easy for it to change from shape to shape. But then it has a definite volume. It does not change its volume. Even though you can change it from container to container, container to container, but it have a definite volume. We can also write that one because it is a characteristic of it. It has a definite volume. Now, what does this mean? It means that if I have 20 centimeter cube liquid, a 20 centimeter cube volume, because volume is measured in cubes. If I have a 30 centimeter volume, the liquid that is in a 30 centimeter volume in a round container, I pour it on the square container, the volume will still be 30 centimeter cube. That is what is meant by the word definite volume. Its volume is fixed. Although it changes from container to container, but it does not change its volume. That is liquid. What do we say about liquid? We say liquid, the particles of liquid are not closely pegged together. They are easily poured. You can easily pour them from container to container. And the particles of liquid do not have the definite shape. What do? They take the shape of the container. Whatever container you put it in, the water, the liquid state, just have no problem. But liquid keeps its what? Volume. So that is why we have a definite volume. Although you can change it from container to container, but the volume remains the same. Now let us look at the particles of a gas. Remember earlier on, we have mentioned an example of water vapor and the other gases that are around us. Air itself, it is in a gas form. Now let us look at how the particles of a gas are. We can also represent them in a form of a square or a rectangle. Now the particles of a gas, they are just free. We can also write, we can simply write they are free, or they are moving freely. The particles of a gas, they move freely. They just have some more space in between. So these particles here, what do? They expand when heated. They expand when heated. I've made an example of water vapor. Remember, we said from a liquid state to a gas state, we have to heat the liquid and so that it becomes the what? The gas state. These gas particles, what do? They expand, then they start to evaporate. So it means the particles of a gas, they do what? They expand when they are heated. Another example, when you blow a balloon, the balloon becomes bigger and bigger. What is inside the balloon? There is air. What happens to the particles inside the balloon? When you heat it, maybe you heat the gas, the water, and then you put the balloon, you heat up on top. The balloon will start becoming bigger. What does that show? It shows that the particles of a gas does what? They expand when they are heated. Do they have a definite volume then, or a definite shape? The answer is the particles of a gas do not have a definite shape. They do not have the definite shape. They also do not have the definite what? Volume. Shape and volume. They do not have the definite shape and volume because they expand. They evaporate to the atmosphere. So now this is how we define the particles of the gas. They move freely. They easily expand, especially when heated. They evaporate, so that they do not have any definite shape and a definite what? Volume. That is the particles of a gas. So far we've been looking the differences of the particles of the three states, where then we can put them in their different in their different forms. Here we have the gas, here we have the liquid, and here we have those that are closely pegged together. So it makes you to be able now to define the particles of each what? State. This one is for the solid because the particles are closely pegged together. This one is for the liquid, not that much pegged together. And this one are for the what? The gas. That is how we define the particles of the three states of what? Of matter. Now, we've been discussing these states of matter. Now, what then? Remember earlier on, we said that matter is any substance that has a what? A volume, a mass, and it takes up what? Space. What then are the units of mass? We say that it takes up what? Space and have mass. I made an example of this pen here in front of me. It means that we can weigh them. All the states of matter, we can weigh them. The units then of mass can be kilograms, which we shorten them as kgs, or it can be grams. They can be kilograms or grams. These are the units of what? Of mass. Grams. So it means that everything, remember I said everything around us is what? Is matter. So if we can measure or we can weigh everything around us according to kilograms and grams. What then does this mean? It means that there are some balances or some scales that are used to measure matter. Because we have different types of matter, we have different sizes of matter, we have so many types of matter. It means we also have the different what type of balances or the different types of scales. Now, how then can we define matter? Matter, we can define it in a form of how does it smell? How does it taste? Remember I said everything around us is matter. How does it taste? How does matter feels? What is the size of matter? Still that is matter. The acidity, still that is what? Matter. And many more other characteristics or features of what? Of matter. How it smells, how it tastes, how it feels, the size of matter, acidity, because it changes, remember, from one state to another. Now, let's take a short break. After the break, we are going to look at how the types of matter changes from one state to another. Don't go anywhere. We'll be right back. I can't sit. I can't sit. Welcome back. We are still on the topic on matter. Now, I promised you that we are going to look at the two types when matter changes from one state to another. When matter changes from one state to another, there are two types. The first one, matter can change in a physical change. In a physical change. In a physical change. The question might come, what is physical change? Physical change, it is the change of matter when it changes it what? Its size. When it changes it what? Its shape. When it changes it what? Its color. But all the changes, whatever change it's going to make, it is reversible. That is reversible. That is reversible. Earlier on, we have mentioned the example of changing or the changing of some ice cubes from ice cubes to liquid, from liquid to gas. We can put it in, it's just a physical change, that one. Why? Because we change the gas back to liquid and the liquid back to the solid state. That is what is made by physical change. The size of the ice cube that did what? They change. The shape of the ice cubes, they did what? They change. Although the color maybe they didn't change, but all in all, the change is what is reversible. That is what is meant by a physical change. So some state, they change in a physical change, meaning they change and they can be reversible. We can also give another example of a physical change. We have in our schools, we have a blue copper sulfate. Blue copper sulfate. Sulfate. Blue copper sulfate is what? Is matter. But it can change from a state to another state. What then? How can we change a blue copper sulfate into another state? We can heat copper sulfate. Remember, we said a physical change is the change of state, the change of color, either of a size, either of one of these things might change, but it must be reversible, because that is what is important. The change must be reversible. Now let's take a look at the copper sulfate here. The blue copper sulfate, as you can see, its color is what? Is blue. But when you heat copper sulfate, what does it do? Its color changes. It changes into white. What then has changed there? The color. But changing a blue copper sulfate into white must be reversible, because we classify it under a physical what? Change. How then are we going to change the white copper sulfate now? Because it is no longer blue copper sulfate. It has changed to be white. We can change the white copper sulfate back to blue. How are we going to do that? We can, it's so simple. We can just add a drop of water. A drop of water. When you add a drop of water into the white copper sulfate that has been changed through heating, the copper sulfate is going to gain or retain its what? Its color. It is going to be back bluish. It's going to turn blue. It is now going to be what? A blue copper sulfate. So that is why we say this change here is what? Is physical, because it does what? It is reversible. Another example of a physical change. Let's take an example of a coarse salt crystals. Coarse salt crystals. Salt crystals. A coarse one. Coarse salt crystals, remember they have a little big, some big sizes. In this case, what are we going to change? The size of the what? The matter, which is what? The salt. What then are we going to do to the coarse salt? We are going to crush it with a hammer. Just crush the coarse soil into soft crystals. We are going to hammer it, or we are just going to crush the coarse salt crystals into soft or fine salt crystals. The salt here has not changed its what? Its taste. But what has changed here? The size and the shape. But now, this coarse salt here must be reversible. We can change it back to the coarse salt. How can we change? Remember, we have crushed it now. Crush. We have to crush it with a hammer or anything that can crush the coarse salt crystals into very fine salt crystals. But remember, we said the physical change is reversible. So it means we have to get back the fine or the soft salt crystals back into the coarse salt crystals. How then are we going to do that? We are going to add water on the soft crystals, make it a salt solution, stir until the salt dissolves. And then what then are we going to do to the salt solution? We are going to evaporate it. There are 2 ways of evaporating a solution. We can put it outside on a hot day, outside maybe on the windowsill, or we can heat that solution, gently heating the solution. When you heat the solution, the water is going to evaporate. And then what are we going to get back are the coarse salt crystals. Now, that is why we say these changes, there are so many changes. You can name a few. There are so many changes that are physical change or that are reversible. Whatever change that is reversible, it is classified under what? Physical change. I said there are 2 changes. Now let's look at the second one, which is the chemical change. We have the physical change and we have the chemical change. So this goes without saying that it is an opposite of the physical what? Change. How then can we define chemical change? We can define chemical change as the change of matter when it changes its what? It can change its state. It can change its shape. It can change its size. And this time it changes its acidity. It changes its acidity. This is more important because this is the first thing that makes it different from the physical change. And all these changes here, or one of these changes here, must be what? Must not be reversible. That is non-reversible. Reversible. This one here is non-reversible. You cannot reverse it. Once the matter has changed, it has changed and it has changed for good. You cannot reverse it, just like the physical what? Change. This makes it different from the physical change. Now let us give examples of some of the chemical changes. Although there are so many, I'm just going to mention a few. Now let us look at just an iron, a nail. Iron nail. I just buy a nail from the shop. You see the color of a nail, so beautiful, so good, so nice. You just put it inside water. Either you put half of it in the water or you put the whole nail inside the water. Put it aside, maybe put it somewhere, maybe for some days, or maybe some hours. What are you going to see on the iron nail? The nail is going to rust. This nail here is going to rust. The question is, can you bring back the color of the nail when it was new after it have rusted? The answer is no, you cannot. That is why this change here is a chemical change. What has happened here? The acidity of the nail has changed. Something has happened to the what? The nail. There's carbon dioxide that has been removed from the what? Then the science, something has been done now to the nail because of the water. So the nail is going to rust and you are never going to bring back the beautiful color of the nail. So this change here falls under the chemical change. Another example. Have a vinegar in a beaker. Have a vinegar in a beaker. Just a beaker. Pour some vinegar in there. And then crush some. Because example here, we're at school. We are going to use the things that are just around us at school. Just crush some pieces of what? Of chalks. crush it into fine chalks, fine powder. Of course, it's going to be fine powder, fine powder. Add the fine powder on the beaker where there is vinegar. You will observe something there. While you are pouring the fine powder of the pieces of chalks on the vinegar, you will see some bubbles there. What does that mean? It means that carbon dioxide has been given off there. Then you will see some evaporation there, some smoke there. Can you bring back that smoke? The answer is you cannot bring that smoke back because carbon dioxide has been given off there. So this is just another example of a chemical change because you cannot bring back the water vapor back to the vinegar. Now, these changes, there are so many changes. There are so many changes. There are so many chemical changes. So many chemical changes. We can name a few. Now, let us look at the volume. Remember, we said that it has mass. What is it? It's matter. The matter that we are talking about. It has mass, it takes up space, and has a mass, and has a volume. Now, let's look at mass. What is mass? Mass now is the amount of matter that is in that particular what? Substance or object. Mass is the amount of matter. Remember we said that everything around us is what? Is matter. But the matter we are talking about takes up what? A space and has what? A mass. What is that mass? It is the amount of matter that makes up that particular substance, that makes up that particular substance or object, whatever it is, because everything around us is what? Is matter. So that is why I said matter can be weighed. We can weigh matter. Because matter now comes in different forms, in different sizes, in different shapes, it means we can match all those objects and substances. That is why we have so many types of balances or scales to measure the matter. I'm just going to list a few. Let's start with the bathroom scale. The bathroom scale is one of the balances that is used to do what? To weigh the mass of people. Where can we find a bathroom scale? A bathroom scale, we can find it in clinics. We can find a bathroom scale in clinics, hospitals, and we also find a bathroom scale on some people's homes. Some people's bathrooms have got this bathroom scale where they weigh themselves every day. Are those people who care for themselves. We find these bathroom scales on, they are weighing because we are also what? Matter. Now, bathroom scale is another type of a balance that is found in clinics, hospitals, and in homes. People's homes have got bathroom scales. We also have another type of a balance scale, which is called a spring balance. Spring balance. Spring balance. Where can we find a spring balance? We can find a spring balance again in clinics. Clinics and hospitals. A spring balance is used to weigh the mass of people, especially babies. They are put inside that thing and then they are being hanged there. The spring balance. It weighs the mass, the amount of matter that is making up that particular person. So it is a spring balance. Clinics. We also find a spring balance in some farms, poultry houses, where they used to weigh the chickens. How heavy are the chickens now? How heavy are the rabbits now? Some farms do have the balance what? Scales. They measure what? They measure their mass, the mass of the matter they have. We have a lot of these things. Some arm lever balances. We have an arm lever balance. Arm lever balance. Such balances, we find them in laboratories where we use them to measure the chemicals in some beakers. We have some arm lever balances. We have some other balances which are called triple beam balance, triple beam balance. Such balances. We have also the top pen balances. Top pen balances. Some balances, top pen balances, are found in butcheries to measure the matter that is in that meat. Top pen balances, triple beam balances. Some balances, they measure the sex of some very big heavy sex, maybe the sex of sugar, the sex of cotton. There are balances. They are all doing what? Measuring the what? The mass of the matter inside whatever it is. And we also have the one which is called a seesaw. A seesaw. A seesaw. This one is just a balance that is found in some of the preschools, maybe, some of the playgrounds where people used to enjoy themselves. You see when the heavy one becomes, the lighter one on top and the heavier one just below, the seesaw. It measures how heavy that person is, although it is not going to tell you the kgs and grams, especially the seesaw. Doesn't give you the kgs and grams, but it gives the amount of matter in that particular matter, or particular substance or object. So these are some of the types of, we have a lot of these balances. Some are electronic balances. We have a lot of these balances that measures what? Matter. So that is why then we define matter as anything that takes up what? Space and has a what? Mass. We also mentioned something about volume. What then is volume? Volume is the amount of space that is occupied. Now, that is occupied by an object. It is the amount of space that is occupied by an object. Again, matter can be measured in volume. Now, matter, remember I said, is different. We have regular objects and irregular objects. But all of these things here, we can find their what? Their volume. Regular object, it's so easier. How do we find the volume of regular objects? It's so simple in that way, because the word regular means something that you can measure with a what? With a ruler or with a tape measure or whatever, but it's something that you can measure it. So how then can we find the volume of a regular object? It's simple that way. Maybe a carton, maybe a box of some pieces of chalks. It's so simple, because where, in that case, you simply multiply length times width times height. By so doing, you are finding the volume of that particular regular object. But then, in this case of irregular, it is not that much simpler. We can use two things then to find the volume of irregular objects. One, you can use a measuring cylinder. Or you can use what is called an overflow can. Remember I said everything has a what? A volume. Now, irregular objects, you can measure them by using one of these two things here, a measuring cylinder or an overflow can. When using a measuring cylinder, it's so simple because a measuring cylinder has some measurements. Measuring cylinder. It is so simple. A measuring cylinder, it's something like that, looks like this. A measuring cylinder. Let's say maybe you want to find the volume of an orange. You want to find how much matter is in that, the space that has been taken, or the space that has been occupied by that particular what? Orange. I said a measuring cylinder. A measuring cylinder has some measurements here. Let's say maybe here is your water here. Before putting the what? The orange. Maybe it's 20 centimeter cube. We want to find the volume of the orange. What the orange or a stone or whatever irregular object that you have. What then do you do? Tie that particular irregular object. Make sure it can enter your measuring cylinder. Make sure it can enter your measuring cylinder, that particular something or particular object. Here is my orange here. You tie it, and then what do? You just dip it inside the water. Make sure your object is fully covered by the what? By the water. What then is going to happen? The water is going to rise. The water is going to rise. The water here is going to rise. Maybe it is going to rise to 40 centimeter cube. How then can you find the volume of the orange inside here? You can subtract then the first level from the second level of the what? Of the water. Because this is the second level. This was the first level of the water, where you have 40 centimeter what? Cube, subtract 20 centimeter cube. We are now in mathematics, but still in science. So we subtract, we have centimeter cube here, we have a 0 here, we have 20 here. So it means the volume of the stone or whatever it is of this here is 20 centimeter cube. By so doing, we find the volume of the what? Of the irregular object, which is then orange, which is a stone, whatsoever irregular object that you want to find the volume of. Or we can use an overflow can. We can use an overflow can. In this overflow can, how then can you find the volume of the irregular object? In this case, you can have a can, you can have a can with a spout. You can have a can with a spout here. You pour water until the water stop overlapping, stop overflowing. And then you take your same object or your same whatever, or the orange. Let's make the orange, the example of an orange. You dip it inside here. But before you dip it, you put a beaker here or a measuring cylinder so that you can be able to tell the volume of that particular object. So now, again, you put that particular object inside that water. What's going to happen? The water will rise, and then the water will start flowing down to the beaker up until makes the level of the volume of the particular irregular shape. By so doing, surely this one is going to give you the what? The volume of the irregular object. By so doing, we've measured the volume of the irregular object. So now, What then were we looking at? We were just looking at matter. We defined matter as any substance or anything that has a space and it has a what? A mass. We even mentioned that matter is in 3 states, which is a solid, a liquid, and a gas. We even mentioned that we can change the state of matter from state to state. We also mentioned the types when matter changes, that there are 2. We have the physical change and the chemical change, where we defined the physical change as the change of matter when it changes its state, its size, its whatever, but whatever changes its color, it must be reversible. And we also mentioned the chemical change, where we said it is the change of matter where it can change its color, its shape, its acidity this time, and this change here is non-reversible. So that is all about matter. Thank you for being with me. Till we meet again next time.